Well, there is a real problem at your screen, and that says a small block is suspended on a weightless, inextensible thread. Alright. At the initial moment of time, the thread makes an angle phi naught with the vertical. You can see there. And the velocity of the ball is 0. That means the ball will be released from rest. And there is first question. What angle does the thread make with the vertical at the moment when the vertical component of the ball's velocity is maximum? Not the ball's velocity. The vertical component of the ball's velocity is maximum. Nice. वर्टिकल कंपोनेंट का मैक्सिमम होगा बॉल की वेलोसिटी का. And second part of the question says, what angle does the thread make with the vertical at the moment when the acceleration of the ball is directed horizontally? Did you guess something? I think these are both are same questions, because you need to consider first of all that the vertical component of the ball's velocity is maximum when the ball's acceleration is directed horizontally. Why? I'm telling you that vertical component of the ball's velocity is maximum when the ball's acceleration is directed horizontally. Why? Indeed, the acceleration is a derivative of velocity, and at that point where the vertical component of the velocity is maximum, the vertical component of the acceleration is 0. Yeah, we all know dy by dx equals 0. It should be 0. At the moment y becomes maximum or minimum, and there is no minimum here, only a maxima exists. So my explanation is the acceleration is indeed a derivative of velocity. Okay, and when the vertical component of the velocity is maximum, the vertical component of the acceleration should be equal to 0. And that means if there is some acceleration, it must be horizontal. It must be horizontally directed. Let us write down the equation of motion of Newton's second law in the projections on the vertical and radial directions. This is the tradition, radial and vertical, not radial and tangential. Now I'm going to write the Newton's second law of motion projection in vertical and radial directions. You can see I have drawn the picture like this. This is the tension force in radial direction and gravity. These are only two forces acting on this ball, a small ball. And I just promised to write down the Newton's second law of projections in the vertical direction. And what is it? What can be it? That can be simply t cos phi. At any arbitrary moment when angle is not phi naught, angle basically ball has fallen some height, and now the string is making an angle phi rather than phi naught as it was making earlier at the start of the motion. It is now making an angle phi with the vertical, same vertical. So at this moment I can write t cos phi equals mg in vertical direction. फोर्सेस जो लगेंगे, और टेंजेंट के लॉन्ग ये सॉरी रेडियल डायरेक्शन में मैं लिखना चाहूँ तो एक फोर्स इनवर्ड है, दैट इज टी, और बाहर की ओर जो फोर्स लग रहा है दैट इज कंपोनेंट ऑफ एम जी, दैट इज एम जी कॉस पाई, and that is going to be equal to mv square upon all L. L is the length, L is the radius of the circle in which this ball is traveling, moving. And so I want to find the velocity of the ball at this moment, and to find this we need to use the principle of conservation of mechanical energy. So the gain in kinetic energy is half mv square, and it is at the cost of potential energy. So amount of potential energy is lost is nothing. If you can see, this height initially was mg L cos phi naught, and now the height is L cos pi. So what is the loss? And the loss is, loss is simply, I was just clearing the things, unwanted things on the screen, and this will be simply mgl cos phi minus final minus initial cos pi naught, and so we can put this is equation 3, so that we can put something t from 1 and v from equation number 3 into equation number 2, and after doing so many things you will get a quadratic equation in cos pi, and that will be something like 3 cos square phi minus 2 cos phi naught. It's a constant value multiplied by cos pi minus 1 equal to 0, and you will get this equation. And after solving this quadratic equation and choosing the positive root of cos pi, you will get simply like 1 by 3 cos pi naught. This is your job basically, not mine. Cos square phi naught plus 3. And we got this problem solved. However, we can do this in yet another way, but I'm not in the mood to do in yet another way, because the same result can be arrived at in another way by simply examining the extremum of the vertical component of velocity, that is v sine phi. This I think v sine phi, v is in this direction, so this is, of course, v sine phi, and as v sine phi we will get in the function of cos pi, in the form of cos pi, and you can get your extremums, and you can equate the derivative of velocity square with respect to cos pi and equate it to equal to 0, and you can get your result. Thank you very much. There is another way, always another way.